So going straight to the scope of today's workshop, it's a well-known fact that buildings are the single largest energy consumer in Europe. Specifically, according to the latest figures, buildings are responsible for approximately the 40% of EU energy consumption and the 36% of CO2 emissions. Moreover, the EU building stock is quite old, with more than a third of buildings being older than 50 years and the 70% of them being energy inefficient. On top of this, the renovation rate is still quite low, accounting for the 1% per year. So in this framework, it's clear that the building sector is crucial for achieving the EU's energy and environmental goals, and in particular, the transition to climate neutral levels by 2050. To accelerate energy efficient investments in this area, the European Commission and the European Union in general has intensified its effort in recent years. Today, I would like to mention just two of the most recent legislative actions that has been undertaken and that are affecting the building sector, namely the Clean Energy for All Europeans package and the European Green Deal. The Clean Energy Package for All Europeans is a comprehensive set of legislations that defines European climate and energy policy for beyond 2020. And it also contributes to achieve the European Union's commitments under the 2015 Paris Agreement on the climate change. The package consists of 8 legislative acts being the result of an extensive revision and update of the already existing policy framework concerning energy efficiency. And as I said before, it is aimed at accelerating the energy transition in Europe. Among the many areas this package is affecting, strong importance have the building sector. In particular, the Energy Performance of Building Directive was amended, including specific provisions for the years to come. So the overall objective is to decarbonize the national building stock by 2050. And all new buildings must be nearly zero energy starting from the end of this year. At the same time, EU countries are required to set some requirements for the energy performance of buildings and to mobilize investments by drawing up a list of national financial measures to improve energy efficiency in buildings. And for the first time in this directive, health and well-being of building users is addressed, considering air quality, ventilation, and the use of smart technologies. In the framework of the package, some other directives were revised. For example, in the new version of the Renewable Energy Directive, a binding EU target is set of reaching 32% of use of renewable by 2030. And in the revised Energy Efficiency Directive, another target for 2030 is set of reducing energy consumption, reaching a 32.5% level. Moreover, with the new governance regulations, member states are required to draw up some long-term strategies and some plans in order to achieve the above-mentioned targets. The Green Deal, in a nutshell, is basically a roadmap which includes actions to boost the efficient use of resources by moving to a clean circular economy and to restore biodiversity and cut pollution. In the framework of the European Green Deal, it is foreseen to start a renovation wave initiative to be adopted in the third quarter of 2020, which main aim is to kickstart the transformation of today's buildings into the buildings of the future. And these renovation waves entails also a new way of thinking the energy efficiency renovation of building, a joined up thinking, because we all know that the building sector is characterized by fragmentation in the value chain. And so it's important to involve all the stakeholders that are important in the different phases of the building life cycle. The European Commission is supporting us in reaching these objectives, and real money are available to foster the transition to energy efficiency building. In particular, the Horizon 2020 Energy Efficiency Program provides support for innovation through research and demonstration of more energy efficiency technology and solutions, and market uptake measure to remove market and governance barrier, addressing financing, regulation, and improvement of skills and knowledge. Just to mention some numbers, an amount of 212 million euros were foreseen for energy efficiency calls in the last 2 years.
Good morning, my name is Daniela Reccardo. I would like to, first of all, to thank Build Up for hosting our webinar and all of you for joining us. I am the project coordinator of Eensulate project, as anticipated by my colleague Paola. And now I would like to present to you the main achievement of our project. Eensulate project started in August 2016, and the official end date is fixed by the end of this August. Unfortunately, due to the coronavirus emergency, the consortium is considering the possibility of asking for an extension to the European Commission in order to finalize all the project activities, with particular reference to the installation of the results in the pilots. The target of the project and of the things that we are developing is existing building as well as new construction. The project has an overall budget of 6.6 million and is developing 3 key enabling technologies, in particular the sealant, the getter, and the foam. The consortium is composed by 13 partners from around Europe. And this is the general overview of the consortium of Eensulate project. The main challenge, as well as the target of our project, is the curtain wall system, because thousands of buildings in Europe have been constructed using this particular technology. And many of these buildings are now old, let's say around 30 to 50 years old, or even more. In addition, curtain wall technology is recently used not only in office buildings, but also in residential applications, such as the construction of residential towers within the urban context. In this particular context, the noise pollution is a key aspect to be considered. Furthermore, windows and glass facades are estimated to be responsible for up to 60% of energy losses through the envelope. Therefore, the replacement and retrofitting of existing curtain walls would allow a significant enhancement in the thermal performances. And in addition, it would help in minimizing the discomfort to the occupants. The curtain wall modules developed within Eensulate project is composed by the novel Eensulate glass based on VIG technology and the Eensulate form in the spandrel combined with low E coated glass, including thermochromic coated glass with additional self-cleaning and anti-fogging functionalities in order to achieve all the thermal and mechanical performances in agreement with the technical and standard requirements, taking into particular consideration also the market drivers. The main technologies at the basis of the products developed within Eensulate project are the vacuum insulated glass with innovative sealant and getter technologies, and the highly insulated foams based on mono-component and bi-component elements. The vacuum insulated glass is realized by Bigitech with a tailored and fine-tuned manufacturing process, implementing the innovative sealant and getter strips to ensure the target performances. Up to now, Bigitech realized already small-scale VIG prototypes, 500 per 500 millimeters, and these kind of prototypes have been tested, and the results are quite interesting because they achieved a new value in the center of the prototypes of 0.36 watt per square meter Kelvin and 0.44 watt per square meter Kelvin as an overall U value. In addition, Bigitech already realized some large-scale VAG prototypes for additional testing in a real environment of 1000 per 1000 millimeters. And the final scope is to produce real-scale VIG for pilot application with dimension up to 2000 per 800 millimeters. Concerning the foam, this particular type of foam is developed by Selena, and it is an highly insulating monocomponent foam, or CF, for Windows application, and a two-component foam with high fire class for spandrel application in the Eensulate module. This innovative foam is a foam with a tailored cell morphology, size, and structure in order to enhance thermal performances through the precise control of the cell's nucleation events, which generate the foam itself. Regarding the sealant, it is produced by size, and it is the innovative sealant is an epoxy resin-based sealant in strips for the application in the vacuum insulated glass. The thermal curing is allowed at, already at a low temperature, below 200 degrees. And this is a challenging innovation with respect to the sealants already available on the market. In addition, SAIS is developing, is working on the possibility of having the monocomponent sealant resin in a syringe dispensable, in a syringe, so that it is dispensable directly by the who will assemble the VIG system in a range of 60 up to as maximum 100 degrees. A key aspect of this sealant is the permeability, because this sealant is it represents an extremely high barrier for argon, nitrogen, and oxygen. In addition, it is also an active filler for moisture absorption. Concerning the use of this sealant, regarding the process, it is mainly done in air with an easy handling. But concerning the storing, it is necessary to stock it in a freezer at a temperature below minus 20 degrees for preserving its properties. The getter is again developed by size, and it is a distributed getter realized with innovative zirconium-based alloy with extremely high nitrogen capacity. The getter is composed by laminated double-side getter strips with a size of 200 micrometers thick and 8 millimeters large. This particular size of the getter enables the utilization in the VIG technology because of the limited thickness. It is again easy handling, and it is positioned in air during the production process of the VIG. The getter activation process is performed by radio frequency heating under vacuum pumping. In Eensulate, we have 3 different demonstration buildings located in the different climatic areas of Europe. 2 of them are placed in Poland and 1 in the south of Italy. The first demo building is a school, a Polish school located in Georgianiov, and the intervention consists in the installation of the renovation of the facade system by installing the Eensulate module. In this particular case, we will install in the Eensulate innovative module both the VAG developed within Eensulate project, that is the innovative solution, and some modules with triple glaze units directly from available on the market. This approach will ensure the possibility of comparing the measurements that will be performed during the monitoring phase in order to assess the actual performances of our system with respect to the system that are already available on the market. The second demo building is the museum, located again in Georgianiov in Poland. This is a very particular application because it is an old building. It is representing an historic and artistic heritage. Due to this, the fact that it is a valuable building with restriction in terms of intervention that can be performed, the type of intervention foreseen in this building is the renovation of some windows. In particular, the intervention consists in simply renovate the original sash and install in the original sash the VAG developed by Eensulate project. And finally, we have the last demonstration building. It is located in the south of Italy, in Pesaro, and it is the San Giovanni Public Library. In this case, the type of intervention is a door window that you can see the photos in the bottom right part of this slide. And considering the fact that in this case the door window is quite new, we simply again install the VAG in the already existing frame. All the three demonstration buildings will be monitored, and the results will be analyzed in order to validate the results of Eensulate project and its product. Finally, I would like to give you a general overview of the main impacts of our project. We can say that we expect the 15% of reduction of energy spent during the whole life cycle of a building, and the 20% of improvement in terms of durability. We can say that the expected lifetime of the VAG is 20 years. In addition, a 25% of improvement of insulation properties because of these particular technologies of VAG, and 10% of enhanced water vapor permeability properties. Finally, last but not least, a reduction of the total cost of the 20%. That's all from my side. For further information, you can contact direct me or ask a question immediately after this speech. Thank you for your kind attention.